Okay, question 9. I'll probably just do A and B in this video, and then I'll do C in the next video. So, part A, it says, write down the first 3 terms in ascending powers of t of the binomial expansion 1 plus t to the minus 1. Okay, it's only worth 1 mark. I've brought in this from the formula booklet. I've brought in this is the Maclaurin series for cos of x from the formula booklet. So, this is the extension of the binomial theorem for any rational number, which includes the negative number. So a plus b to the n, a is 1, b is t, n is negative 1. Fairly straightforward. 1 to the power of n, so I can ignore this because it's just 1 to the power of n, which is 1 to the minus 1, which is 1. So I'm going to have first term, second term, third term. First term is 1. Second term is plus n, which is minus 1. b is t, and a is 1, so it's just minus t. And then here I'm going to sub in minus 1 here, so I get minus 1 times minus 2, which is 2 over 2 factorial, which is 1, so that's all 1. And then I get t over 1 squared, which is t squared. So it's, sorry, did I say minus 1? It's minus times minus is plus, so it's just 1. 2 over 2 is 1, and I'm left with t squared, so it's plus t squared. This is, sorry, I should have written that down. This is 1 plus t to the minus 1. Okay, part B. He then says, by using the Maclaurin series for cos of x, that's this here, and the result from A, fine, that's this, show that the Maclaurin series for sec x up to and including the term x to the 4 is this. Okay, fine, that is obviously a difficult question. So first thing to get clear is sec x is equal to cos x to the power of negative 1. That's what it is by definition, is 1 over cos x is sec x. So I can write this. Okay, but I can't just say that, well, I could say sec x is 1 over this, but that would give me a lot of problems. And he says by using this result, so I'm going to use this here. So here I have cos x to the minus 1, and here I have 1 plus t to the minus 1. So we're going to let 1 plus t equal cos x. If you let that equal to cos x, now I can say that this is cos x to the negative 1, which is sec x. So if 1 plus t is cos x, this gives me sec x. So t is equal to cos x minus 1. Okay, so now I can say cos x to the minus 1, which is this thing here, is equal to 1 minus t, which is now this thing, cos x minus 1, plus t squared, which is this, cos x minus 1 squared. Okay, but he wants me to show this, so I'm going to change my cos x into this, and I can just stop after the first 3 terms. So it's 1. By the way, this 1 minus 1 is going to cancel here, but anyway, let's deal with that after. Well, actually, because this one's going to cancel, so don't worry about it. So 1 minus cos x is 1 minus x squared over 2 factorial, which is just 2, plus x to the 4 over 4 factorial, which is 4 times 3 times 2, which is 24. I'm going to put that in like that. And I'm going to, and it's minus 1 because of this minus 1. So that's cos x minus 1. And I'm going to close my bracket. Now, actually, technically, I should do here dot, 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 because it does continue, but I only have to care about it up to the power 4 term, because that's what he wants here. Anyway, I'll do the dot, 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 and then the minus 1. And then here, I'm going to have plus, same thing, 1 minus x squared over 2 plus x to the 4 over 24 dot 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 minus 1, close the bracket, squared. Okay, so this equals 1, which is fine, which I want. By the way, this one and this one now cancel, and this one and this one cancel, which is good. So it's gonna leave me with this x squared over 2, but it's minus minus. So this is plus x squared over 2. And then minus plus, which is minus. So this is minus x to the 4 over 24. And I'm going to stop there. And then this is all squared. So what happens is I have to multiply. Remember, the one is now gone. So I just have my minus x squared over 2. So I'm actually going to square this whole thing here. But I have a square term, a quartic term, a to the power of 6 term. Essentially, once I multiply this x to the 4 term by anything else, because remember the ones are gone. Let me just get rid of them to be clear. These are gone, and these are gone. So when I multiply this term by anything, it becomes at least an x to the power of 6 term. So I can basically ignore that, and all I'm left with is this x squared over 2 square term, because I will have to multiply it by itself. Yes, it's negative, but when I square it, it'll become positive. So that becomes plus, that's plus x to the 4, because I'm squaring my x squared, which is x to the 4, over 4, because I'm squaring my 2. So I'm nearly there. Look, I have 1 plus x squared over 2. I just have to turn that into x to the 4 over 5x to the 4 over 24. So let's just do that very quickly. They do say show it. So it's plus x squared over 2 minus 1x to the 4 over 24 plus 6. This is 6x to the 4 over 24 using equivalent fractions. 6 over 24 is the same as 1 over 4. And that is the 5x to the 4 over 24 that they want. So that gives me 1 plus x squared over 2 plus minus 1 plus 6 is plus 5x to the 4 over 24. Nice. QED. I have shown what they asked me to show. Okay, I'll do part C in the next video.